Okay, this is the 2015 AP Calculus official practice exam. This video is going to cover free response number 1 and number 3 with emphasis on the 2020 test. So number 1, I'm not going to draw this on my whiteboard, so just follow along on your paper. Number 1, we've got a graph, and it's about a tank, and water is being pumped into the tank. Starts with 100 liters, water's being pumped in according to this linear function right here. And it's over a 55-minute period. So part A says find R prime of 45 using appropriate units and explain the meaning in the context of the problem. That last part, explaining the meaning, is going to be really important on the 2020 test, I believe. But to get R prime of 45, what we need to do is get the slope of this line, because 45 lies on that line right there. Okay, so that'll give us R prime of 45, which R prime is just a slope. So part A, R prime of 45 is equal to the change in Y over the change in X. Okay, so just looking at the graph, y ends up at 0, so y2 is 0. y1, okay, y1 here is 30. So we're just getting the slope of that line. And then x2 is 55. And then x1 is 35. So that's going to be negative 30 over 20, so negative 3/2. Okay, and then the unit, just look, it's y over x, so it's going to be liters per minute. So liters per minute squared. Okay, that's R prime of 45. Now the explanation part is half of the points on this problem. So what is the meaning? Okay, so the meaning is that the rate, because remember, R prime is just going to be a rate at which water is pumped into the tank. So the rate's going down, right? It's decreasing. Negative is decreasing at a rate of, that's redundant with the two rates, but who cares, of 3/2 liter per minute squared at time of 45 minutes. So don't poo-poo the explanation part. The explanation part's half the points on that one. Okay, part B, I think I can fit onto the whiteboard here. So part B says how many liters of water has been pumped into the tank? Okay, so that's going to be from 0 to 55 of R of t dt. Okay, so if this were a function, I don't think you would see this on the 2020 test, but this is something we can figure out because it's just the area under that curve. All right, so what I'm going to do is divide this area. So from 0 to 20, we have a trapezoid. So I could add that up. From 20 to 35, we've got a rectangle. No problem. I can get that area. And then from 35 to 55, I've got a triangle. Okay, so that is equal to the area under the curve from 0 to 55. All right, so for the trapezoid part, remember, a trapezoid is the base times the average height. So that's going to be, the base is 20, and then the average height, it's the average of 10 and 30, right? So that's going to be 20. So base, average height. So that's the trapezoid part. And then you get from 20 to 35 a rectangle. So 20 to 35, the base is 15 and the height is 30. Now you don't have to write all this down on the 2020 test. I'm just doing that for you to help explain. And then the last part is the triangle. The triangle base goes from 35 to 55, so that's 20. And then the height of that thing is 30. Okay, so that'd be 400 plus, all right, 30 times 30 is 900, so 30 times 15 would be half of that, so 450. You get to use a calculator. And then half of 600, 300. So that's going to be 700 plus 450, which is 1150. What's the unit? Well, it's liters. It's water being pumped in. Totally could have one like that, I think, on the 2020 test. All right, part C, I don't really think would be on the 2020 test. But I'm going to go ahead and do a quick solution on that one because part D could be, and it refers to part C a little bit. So remember, this part is a calculator question, and of course you won't have that on the 2020 test. But 1C says at time t equals 10 minutes, water begins draining out. And D of t is equal to 10e to the sine t over 10 liters per minute. Water continues to drain until 55. So how many liters of water are in the tank at time 55 minutes? Okay, so on this one, you know, the tank starts with 100 liters. And then based on part B, we added 1150. And then you start to drain at 10 minutes and you go all the way to 55 of d of t dt. So that's how you would get it. And the number is about 800. But that's not going to be on the 2020 test. But I wanted to go ahead because a question like D could be, and I wanted to go ahead and show you where you got this number so that we can refer to it in D. That would have been an easy one to do if this were a normal year. So anyway, let's look at part D. It says, using functions R and D, determine whether the amount of water in the tank is increasing or decreasing at t equals 45 minutes. Okay, so R at 45, you just read the graph. Okay, read the graph and it's looks like it's about 15. Okay, that's the rate. So that'd be liters per minute, right? About 15 liters per minute. D of 45, you would plug in. Okay, D of 45, plug it in right here. If you put that in your calculator, it'd be like 10.9. So since R of 45 is greater than D of 45, the water in the tank is increasing. So they're adding it with a pump faster than it's draining out at that point. So you could have a question like this. It's just they would give you the number that you could just plug in. It'd be easier math than having to plug in a difficult function like here in D. All right, that's number 1. I want to go ahead and do number 3 on this video. instead of breaking it up into two really short videos. So skipping over number two. Number two is very much not, I think, a 2020 test. Number three is great. It's a great problem. It's the classic problem with the table, right? And there are so many of the practice problems have one of these tables on it. I just feel like they're going to give you one of these. If they don't, they don't, but boy, does this keep popping up, doesn't it? So I'm not going to write the table, so just follow along. I'm not going to write the table on the whiteboard, so just follow along here. So this Kathleen skates on a straight track, rest starting time between 0 and 12 seconds, and her velocity is in the bottom of the table here. And part A says, use the data in the table to estimate Kathleen's acceleration. So we know that acceleration is equal to the derivative of the velocity. Now, we don't have a function, but we do have a table, so that's going to be the slope at t equals 4. Now, we can't get a tangent line slope here, but we can get a secant slope. That would be our estimate, so we're just going to use, I want to mark on this, we're going to use the data between 3 and 5 here. So at t equals 4 seconds, we can get a pretty good estimate if we get the slope between 3 and 5. Okay, so a of 4 is approximately equal to the change in y over the change in x. The change in y is 10 minus 5, and the change in x is 5 minus 3. So that'd be 5 halves. And then to get the units, it's going to be feet per second, y over x. The units for y divided by the units over x. So feet per second is feet per second squared. All right, and it doesn't look like we have to explain anything. The units would be important there, so don't rush through the units. All right, part B. Beautiful. It says using a Wright-Riemann sum to approximate 0 to 12 of k of t dt. Okay, is it an overestimate or an underestimate? I think it's a possibility you could get one like this. Okay, so the Wright-Riemann sum, so 0 to 12 k of t dt. Okay, when we integrate velocity, what do we get? We get position. Okay, so our units of measure are going to end up being feet. So how far did she skate during this period? Okay, so our first base is from 0 to 3, so that's 3. And the right height would be 5. The second base is from 3 to 5, so that's a base of 2. The right height is 10. The third base goes from 5 to 8, so that's 3. And the right height is 20. And then the last base goes from 8 to 12, so that's 4. And we've got a 24 there. Okay, so you would get a little calculator that you could, any kind of calculator you want. 15 plus 20 plus 60 plus 96. All right, it's kind of nice that you get a little calculator there. So that's going to be 191 feet. So we have indicated, is this a overestimate or underestimate? So a Wright-Riemann sum, so we know this is an increasing function, right? So it starts at 0, 0, and it's going up, an increasing function. A Wright-Riemann sum overestimates an increasing function because you've got this extra material up here above the curve, right? You don't have to draw that, I don't think, but it kind of helps. So it is an overestimate because a right Riemann sum, let's just say a right sum, overestimates an increasing function. So if it were a left sum, it would underestimate it. If it were decreasing and you drew it out, you would see that the right sum underestimates. Okay, so hey, you may want to write this down, just have a little table for you. So if it's a left, okay, so if the function I'm doing this on the fly here. If the function is increasing, a left sum under and a right sum overestimates. If a function's decreasing, the left sum, it's opposite. A left sum over and a right sum underestimates. So you could draw it out or just learn that table. Have that table ready for you on test day. Okay, cool. That's part B. We're moving along. Let's turn the page and look at part C. All right, part C says Nathan skates on the same track starting 5 feet ahead of Kathleen at time t equals 0. Nathan's velocity in feet per second is given as n of t is equal to 150 over t plus 3 minus 50 e to the minus t. Write but do not evaluate an expression involving an integral that gives Nathan's distance from the starting line at time t equals 12 seconds. Okay, I don't think this is going to be on the 2020 test because it's an integral involving a velocity, position, acceleration type problem. I'm going to write it down real quick anyway. He starts at 5, so his position, s of t, would be 5 plus from 0 to 12 of n of t dt. It actually would be the absolute value of n of t in case he starts going back and forth. Okay, but you know, that would get it. So that'd be s of 12. Okay. All right, and so I don't think that'd be on 2020 test, but part D might be. It says write an expression for Nathan, okay, so that's this guy, n of t here, acceleration in terms of t. So this could be on there. We know acceleration is equal to v prime of t. So in our case, that's going to be n prime of t. Okay, I'm going to rewrite n of t to make it easier to take the derivative. I think it's a little easier. Instead of doing a quotient rule here, let's rewrite the denominator as t plus 3 to the minus 1. So n prime of t, bring the minus out front, so that's minus 150 times t plus 3 to the minus 2 times the derivative of the block. Well, the derivative of t plus 3 is just 1. All right, and then minus 50 e to the minus t times the derivative of negative t, so times negative 1. So cleaning that up, it would be negative 150 over t plus 3 squared. I don't even know that you'd have to do this to make the exponent positive, but I did it. Negative, negative makes a positive. You could probably just circle all this and just make them, you know, count it wrong. I don't think they could this year. And there you go. There's the expression for the acceleration. And that does it for this video. I think both of those problems were really good to study. And our next video, which I think is going to be our last video, will cover problems 4, 5, and 6, or at least the parts of those I think relevant on the 2020 test. So I'll talk to you next video.